Hello.
Hello.
How are you?
I'm good. How are you?
Okay. All right. Vidhi, you've been very enthusiastic about your midterm evaluation, and you have a post. Would you like to walk through the post?
Okay. Yeah, it's actually not like completely ready. It's just like an outline, and I'll add the formula, whatever I've used. I'll try adding some images. It's just like the first draft for now.
Okay, that's fine.
Yeah. I was just worried about it because it's like the midterm evaluation. So.
Oh, well, I mean, yeah, the way I approach it is pretty formal. It's a formality unless you've not been showing up and giving updates.
Yeah.
But yeah, I'm glad to see that you've gotten a lot of things in place for that. So why don't we go over that? We'll start off with.
Oh yeah, is my screen visible?
Yes.
Okay. So I would like to go through both week 5 and 6 because we didn't have a meet last week. So in week 5, I was optimizing the SARSA agent that I had introduced in week 4. So let's just recap week 4. In week 4, I showed that this was the output, that there are 10 agents and those agents are being classified, and based on what tasks they do, everything like based on what tasks they do, the success rate is being defined, like it's calculated after each step. So if we see this is step 9 and this is step 10, and whatever's happening in step 10, like some tasks are being allotted and those are being done. So over here, I think it was for agent 5 we had done that. Over here there are 63 successes. It's a contributor. And then this is step 9. So in step 10, it has been allocated the bug task and then it does it. So it becomes 64 successes. So the success rate also gets updated. So in week 5, I was just going through all the edge cases. Like for example, we see C2 is a contributor, and even though it has 100% success rate in both, it's a contributor because it has solved more of these bug tasks. Then again, coming back to C2, even though it has a 100% success rate in the feature tasks, it is still a contributor because it has done more of these bug tasks. So whether it's what kind of agent it is depends on the number of tasks it has done and the ratio of it with the failure. Then I just wanted to visualize it a bit better. So I had a graph for it, and each contributor agent will have some kind of success rate. So the same success rate which is mentioned over here is visualized in the graph. And based on that, like the darker it is, the higher the success rate. And blank means it hasn't done anything, so it's like 0%. Then I added a few agents, like I added 5 more agents. So earlier there were 10, and then midway I added 5 to test exploration and exploitation. So because once like over here, if we see, it'll start exploiting, but then the exploration part should never stop. So to make sure that exploration and exploitation are still going on and it's not just exploiting, I added 5 agents midway. So it started exploring again. And then this was just after a few more steps. So yeah, this is how I'm storing the queue values. Like there's a data folder in my directory, like in the main GSoC directory, there's another directory which stores all the queue tables and it gets some queue values. And again, the main reason I'm not pushing these because these keep changing. So except for these data and JSON files for queue tables, I push everything on my GitHub. And yeah, so basically week 5 was about optimizing the code, adding more agents, and then testing. And then I changed a few reward functions. So this is the blog, and I had texted all the mentors to just update them. So week 6, so I was already done with the salsa part. So in week 6, I went ahead and I started doing something which is there after the midterm evaluation, which is the harmony index. So the harmony index actually measures how smoothly and fairly the agents will collaborate in a system, and it combines the tasks and the task success and the load balance. So the load balance is actually 5 tasks per agent, but the load balance never overloads because in each step we're actually having only 3 tasks. and those 3 tasks may or may not be allotted to the same agent. But still, if we increase the number of tasks, yeah. Am I audible? Yeah.
Mm-hmm.
Yeah, sorry. So that's about the harmony index, and we use it so that we know what like the value of the harmony index can help us know whether our salsa agent is doing well or not. So yeah, this is the significance that this is just like pretty formal, but the last point is the most important one, that we get some feedback or optimization of the salsa or the multi-arm bandits. So for harmony index, I've used this formula, which is inspired from a paper. I'll add the link to that paper as well. So the formula is alpha into average success rate and 1 minus alpha into the fairness rate. So yeah, so this is from the Markov paper, like the Markov's games paper, where they have used a utility formula where they calculate the utility with alpha into utility 1 and 1 minus alpha into utility 2. So instead of just utility 1 and 2, I've added the like I've replaced it with the success rate and the fairness score. So we here I've chosen alpha as 0.6 because it's slightly more than more than the importance of the success rate and 40% fairness. So yeah, that's the reason why I chose it. So this is the value that I got. Like I was printing the harmony index after each step, which is 0.854. So we get to know that the salsa agent is performing well, because if it's too close to like the alpha that we have said, that means it's not performing well because the success rate is not high. So if it goes above if it goes a bit above the alpha that we have said, that means that the success rate is good. So yeah, this is again the same graph for another few steps. And this is what was happening. So I plot a graph for the harmony index as well. So in the first few steps, it was ranging between like 0.5 and somewhere between 0.8. And then after a few steps, it was close to 0.8. So it improved. And yeah, that's it. Then I have added the week 6 block and a block for what I've done till the midterm evaluation. And yeah, along with that, I updated the README file. That's it.
Okay. Thank you.
Yep.
Yeah, it looked good. I was looking over. You sent me some work from last Saturday, and I was looking over the work, and I had some questions about the different types of contributor. So if you could go back to that slide that you had up, because I wasn't sure. Yeah, I wanted to make sure I could walk through it.
Okay, yeah. Is this the one or like?
Go back further.
This one.
That one, yeah. I guess that one would work. So this is
okay.
So you have the 3 classes of agent: knowledge curator, contributor, or an innovator, but it's not on this one. So you have they're doing bugs, features, and docs. Yeah.
Yeah.
And then they're doing they just do them as they encounter them, or they don't do them.
So it depends. Like which I had shown in week 4 actually, that if so for example, if a task is allocated, now it has 2 options. So it can do the task or skip the task. So if it does the task successfully, it gets a reward of +1. And if it chooses to do the task and still fails to do the task, it gets a negative reward, which is -1. And if it skips the task, then it gets a reward of 0. So based on that, it keeps getting added cumulatively over here. And like I'll try zooming in a bit actually. Like if you see over here, a contributor is supposed to do more of the bugs. So in each of the files, like in each of the agent files, I have given a higher reward to the contributor for doing the bugs and lower reward for doing the other 2 tasks, and similarly for the other 2 agents as well.
Okay.
So contributor does bugs, innovator does features, and knowledge curator does docs.
Right,
basically.
Yeah.
And so you are defining this in the beginning only, or is it that based on the fact that they are doing more feature tasks, they become an innovator? Or you are saying that
become an innovator? I'm not saying anything. It changes. It keeps changing. So like eventually, like if I delete all the data and the JSON files that I have, and if I run it, then first according to multi-arm bandits, everything, the tasks will be allotted, and based on these 3, like basically skip task and do task, whatever it does, and after a few steps, then like depending on what task it has done, it gets a higher bias for doing the tasks it has done better. Like for example, over here it has 44 successes. So like eventually in the next steps also it will do more of the feature tasks. That's how it's classified into the special type of agent that it is.
So in this first step, C1 will be nothing. It will not be an innovator or a knowledge.
Unclassified, yeah, it's unclassified. Like I'll one sec. I think it was there in the week 4 one where it's like unclassified. I'll try finding a picture of it.
Okay.
So here, I think all of them are defined. But oh yeah, over here, yeah. So this is again when I was running for the harmony index for the first time or something. Like it's unclassified. Like I think this was after 10 steps or something, and it has done nothing. So it's unclassified. So until it does until a few number of steps, when it does something, it will be classified into the type of agent it has expertise in solving tasks.
That's good. Thank you. I guess we had someone who wanted to speak. I don't know. It's that fellow Jitster. I don't know who that was. Was that Sarrah? Okay.
Yeah.
All right. So that's good.
Yeah. So yeah, one of the questions was related to what Bradley asked, and then I handed over. One of my other questions was I had asked you to see if like this knowledge curator, contributor, innovator kind of classification is present in any literature. I don't remember if you had sent me anything regarding it or not.
Yeah. It was not like it's not there in any literature, but it's from the Reddit articles that like there were a few Reddit articles that I read that if this was possible, and also I had mentioned like when I spoke to you earlier that a few other organizations like when my friends were contributing to NumFocus, that's what was happening. So my inspiration is taken from there. But yeah, I'll definitely send you the Reddit article that I read or something.
Because you're taking those specific names, I think either
Right.
I mean, what you're talking about, knowledge curator, is definitely a thing. But because you're taking those names, we can either try to find some pre-existing literature for it, or if there isn't, then we can very specifically define what it means, and then show some sources to explain how we have arrived at that definition.
Yeah. So the name I'm using, sorry. So the name that I'm using is actually given by my own self, but the fact that I came up with this is from NumFocus itself. So I can give NumFocus the credit for it, and the name can be defined.
Yeah, sure. Or you can also try to find if there is any existing literature where there's something similar with another name, then go with that. If not, then you can do what you said. Like you can try to define it.
Okay.
Yeah. And like my third question was, so I noticed in the when you were showing the Q learning, so there were most of your success rates were in the 90s to 80-90 range, and very few were 100. And when you added the Harmony index, most of them were like 100 for one task and 0 for the other tasks. So is that like it is not exploring at all? It's not trying to do any of the other tasks. Is that what's happening?
I don't know how that two Vidhis. Sorry. Yeah.
Oh yeah, no, that happens when like the old one doesn't feel good. So that's
okay.
Yeah. Did you hear my question? Should I repeat?
Yeah, about the harmony index, right? Like the success rate. Like I accidentally left midway, so I didn't hear. Yeah.
Yeah, I was saying that I noticed that when it was Q learning, your success rates were in the 80 to 90s range, and then some were like 9800. But in Sarsa, I noticed that when you added harmony index, I noticed that it was like 100% for one type of task and completely 0 for the others.
No,
so
I don't.
Is there like some reason why that's happening?
I don't
Maybe
think
I thought it was
like it was run for two different, like the previous images that I showed before harmony index were from week 5. So that was a whole different 10 number of steps that I had run before, like each time.
Yeah, exactly. This is the image I was talking about. It's like 100% of the one.
Yeah, because this is like 2 successes right now, and I had deleted all the data files over here, like which I mentioned, like data and then this qtable.json, and then there's one other agents.json file. I deleted everything and I started everything fresh because I didn't want this to be as a previous memory. I wanted everything to start again. So that's why it was 100% and 0% because it's the very first time I run the code. But then when I run it after a few more steps, it will get back to the other rates. Like, I think, yeah, so this was the first image that I done. And then when I took a picture of the graph, it was still later, like after running it for a few more steps.
Yeah,
Over here,
still C10 is the ones without harmony, right? And C11 onwards are with harmony.
No,
All
there's
are
nothing
harmony.
like that. All are with harmony. Also, harmony index is not related. Like it has, they are two independent things. So once the agents do something, the harmony index is calculated from the average success rate.
Yeah, and then that harmony index is helping you optimize
To
the
know
rewards
whether-
at each step.
Yeah,
right?
yeah, correct.
Yeah, I mean, I was just worried that it was, going very much into exploiting and not exploring. That is why it was getting this 100%. Because even here, like C7 has like 100% for 2 tasks, for example. Okay, if it's because it's like for fewer steps, then that's fine. I just
Yeah, for
noticed
the
it
first few steps. Yeah.
Yeah, you can run it for more and see the behavior.
Yeah. I'll definitely run it for more and then I'll send you the output. Actually, like next time onwards, I should add 2 different graphs to even show the growth from the first, like the initial steps, and then yeah, correct. I'll do that.
Definitely. Yeah.
Okay.
Thanks.
Sure.
Okay, that sounds.
Are there any more questions? Okay.
Yeah, I think that's
Hello.
that's fine. Yeah. Thank you,
Okay.
Vidhi.
Yeah,
Yeah.
thank you.
Yeah. So next, who wants to go, Lalith or Jayadratha?
I'll probably give the update from my side. I have
Alright.
2 things to share this week. So I pushed the code today. So yeah, so I worked on the growing hypergraph, so the dynamic part, so which I discussed last week in the DevoGraph meeting, like how I have progressed and all. So the quick update from like previous week to this week is I actually divided the multiple modules into a simple class where it has a dynamic, like growing hypergraph. Here I have integrated 3 main crucial components, which I thought I would need it in the future. I mean, like I thought the integration and the streamline procedure could actually help me to experiment with these. And it's always good to have this the overall pipeline ready. So the first thing I tried is like I integrated 2 hypergraphs. So one is hypergraph convolution and GAT, and then I after the accumulating these convolutions, so I discussed in the last week that we need a sequence model which is aware of the time steps, which means that we are able to extract the features which starts from like a simple single cell and it grows like an adult. So when it during the growth process, so we try to understand at each time step how it's changing, and in order to understand the time step the details, so we have to use a kind of transformer or GRU. So last time I implemented GRU, I thought it's not sufficient. So I also integrated GRU and also the LSTM into the pipeline. And also I thought in the future, because the transformers and large language model, the foundation models are like playing the crucial role. I thought adding these transformers into the pipeline itself, which actually might help in our future. So I actually added the transformer part too. And I have created an end-to-end pipeline where we have first convolutions, where we have the details of like the lineage information extracted from the hyper edges, and coordinates extracted in spatial the spatial XYZ coordinates from the each and every hyper node, and these have been transmitted into either, if you want, and this is like an optional block transformer. So if you have a larger pool of data, then transformers actually he has the potential to scale. So I added it, and then we have a recurrent neural networks which actually are aware of the time steps that we want. So when we use an LSTM, then it will actually run the LSTM. If not, we'll use RNN. Or if you want a certain GRU or we want a certain type of cell, then the exact formulation can be used. So here I've given in the function calling. So when we try to call what is the kind of RNN type that we want, so when we specify it, then it will take care of the job. So yeah, and in the final we have a readout function where it actually embeds in all the features into that. So the last three states. So this calling example I've given one, which is like we can use hypergraph GCN, hypergraph convolution, and then a GRU without a transformer. Here you can use a GAG convolution with GRU, and also we can use the transformer. This is like the way we call. And the training pipeline is the same. So I'm in the verge of understanding the visualization which I have shown in the last week. I mean, like I was able to plot the embeddings of the hypergraph, the hyper edge it's trying to understand. So I am still trying to understand that which network actually plays a crucial role. I'm trying to label. I mean, like label in the sense we already have the labels, but in the visualization when we are trying to label that, it actually having a little messy look to it, and which I didn't like it. So I'm working on the visualization part. How do I have to embed the I mean like these text information into like each of the cells, so that we can easily visualize and bring what are the cells that actually come together during the process of the embryogenesis. So that's this week, and next week probably I will bring out the visualizations. Once the visualizations are done, then probably the most of the part which I'm trying to understand will be resolved, because the neural networks what I have used for the previous time, and this model and the entire pipeline makes sense when we have the right visualizations on the plate. So I think I have the thing that I have to discuss for the next week. And if the if you permit, Bradley, I can probably discuss about some of the details that we got data from like Nikhil. I have mailed you. Did you check mail?
I did see that. Yeah. Yeah, that's
So
good.
So Nikhil has given the data of his report, that interactive lineage tree. So I was able to understand where exactly the synthesiums have been formed, and which cell was actually responsible. And I had a small summary statistics. If you want me to discuss, I'll probably share that.
Yeah, you can go ahead.
So what I have seen is when I took the data of the Nikhils, and when I able to understand. So the hypoderm 7 was like the most frequent thing that it was seen. And it was count was like 132 times, which was seen in the entire lineage tree. So, and there were like hyperdemic 6, 4, 5, 3, 1, and these are the rare things. So what I have observed and read about all these things, and I got to understand is, so the hypoderm 7 appears like most frequent times, like 88% of the times, and we have seen these rare synthesions like hypoderm 1, 2, 1VDR. I didn't was able to understand exactly what they mean, but I understood that this handful of distinguishable hypodermal synthesium cell types can actually dominate the data set. So this domination might lead to I mean like I don't know, but when we try to visualize and when we see it, then maybe it will make more sense. Why they actually are like more in number, and why are they rare in this number. So, and how are the connections from the hypoderm 7 to like other these, and how is hypoderm 1 TL is connected to the remaining thing. So that could be an interesting line of thing which we can see in the future. So that's what I was able to do. Yeah.
Yeah. So this was something that you did. This analysis was something you did.
Yeah. This
All
this
right.
one that's which happened.
Yeah, that's great. Yeah, please send that to me.
Yeah. Sure.
Looks good. Yeah. Thank you. Yeah. So this is from this data from Nikhil Bhatla, who does the interactive lineage tree.
Right.
Yeah.
Right.
Okay.
So I took the cell.txt have given us like two data sets, and of which one I have taken, and from which I was able to do this.
Okay.
And I'll share the data set and also probably the code.
Okay.
So
That sounds
so
great.
yeah. So I think the visualization part, which I'm thinking, would actually make quite a lot of sense, because when we try to visualize the hyper edges, then it will make us understand that which actually type of cells are coming together, so that we will be able to understand which plays like a significant role. So probably I'll work on the visualization part, because I was able to embed, I was able to extract the embeddings of how the neural network trajectory is learning. So we have the topology right now in our hand. So when we have the neural network topology in hand, I believe that so it's more useful that from a neural network standpoint, how the embeddings have been come together during the embryogenesis. That will give us like quite a lot of information. So that will fetch us like an very informative outcomes. So I am facing this issue because of two reasons. One, there is no existing Python library which actually visualizes well for the hyper nodes. I mean, like, or the hyper edges. And when we are trying to I have seen a certain type of visualizations like the Euler diagram, and there are like few other variations of it which were not open sourcely available. And I mean, like, not open source available in the sense they have not implemented any of that yet. So I think I have to look into that. That's a crucial part which I'll probably bring it on next week. The visualizations will actually make a sense. They'll make us understand that from where we started and where we ended, and what we are trying to extract from that. So that's my so next week.
All right. That sounds good. Yeah. Thank you.
Yeah. So any suggestions is
Well, I mean, I think you're doing pretty well. I can't see any suggestions to make now, except when you're doing like an analysis, make sure you keep notes and everything. It looks like that's what you're doing. So, and please send me
Sure.
the document you're working on, because I'm
sure.
kind of collecting everything.
Yes.
Okay.
Okay.
Thank you. So, the Jayadratha, you're up next.
So, for my project, this was the outline we thought about doing. I thought about doing. That is, at first data set pre-processing, and then building a DTDG framework, and then modeling temporal graph. Embryogenesis to temporal graph network, and then the connectome data uh, through this temporal graph network. So this part has been done. The data set part, I have tried on one data, that is how the cells are growing, and basically the embryogenesis. And then we created instead of discrete time temporal graph, I created a continuous time dynamic graph. That is because uh, like I have discussed that why it is more suitable for CTDG, and this part has been done. And also I was working on this dynamic graph modeling. Instead of virtual GCN, we have tried on TGN, that we have done on the dataset we have created, that is CTDG dataset we have created, and on that we ran TGN, that is temporal graph network. And now the part that is left is like the modeling connectome, and it's like different biological growth processes, and then run some kind of temporal graph method. So for this one, few things are left. That is, like we have run only on TGN, but as I told last week, I will run on other different methods that are available for benchmarking. And but for the connectome, like for modeling connectomes, I was trying to understand what are the data sets, publicly data sets that are available. So I found this one, and like so I found this one, but I'm getting a little hard time understanding this. So, like what I understood from the paper, this nature paper, like so I think it is different, uh, I think 8 different snapshots of the connectome data. So I was thinking, and these are the different L1 dataset, L2 dataset, L3, and this adult dataset. This is how the connection are. And what I understand from the overall, like from this, I mean reading, I didn't read the paper completely, but what I understood is basically the connection that is also changing with time. I mean the connection strength. So overall, uh, I mean the connection is same. I mean what are the who is connected to who, that is, and the number of uh, like these things, those are probably same, but the connection strength that is changing. So I like here we can perfectly use DTDG. So this is made for DTDG. So previously for cell development, we have used CTDG, continuous time dynamic graph, and for this one, I guess we can use DTDG. So for that, like I mean, I was reading this, and this is very new to me. To be honest, I didn't understand much about this data set here, uh, and I tried to understand like few of the how it is growing and all, but mostly I was not able to. So here I have to do like how we can frame this data as a graph, and then like plot the data, and then I guess it is already there, the plot and those things, and how we can use DTDG on it. So like I don't have much in this week, but this is what I was reading and trying to understand. So is it the like can we work on this data, this and go ahead with this? Because I was very confused about connectome data. I didn't find much of the data that is available and that we can work on. But I found this is the perfect, perfectly fitting of our need. So I want your input regarding this.
Okay. Yeah, I can give some input on this. So, yeah, this is a good paper for kind of understanding how things change in larval development. So, we talk about the embryo and cells, dividing on the lineage tree and then differentiating into neurons and other types of specialized cells. And then, of course, we talked about the post-embryonic tree, which is after hatch, and there's some cells that are born then, but mostly cells are differentiating, they're fusing to form syncytium, things like that. What you have here is the connectome, and different people have proposed different connectomes. You'll find like different data sets, and so the one version of the connectome is there's a male connectome and a hermaphrodite connectome, but let's focus on the hermaphrodite connectome. One is based on these gap junctions or these electrical connections, and so this is where the cells come into contact in some way. And so people have mapped out those connectomes. That was like the original connectome by John White, and so that's the one that we always go to for understanding the connectome and how things are connected. And then we have this kind of connectome, which is a synaptic connectome. And so this is where we have axons that connect to cells, and then at the ends we have synapses that you have multiple synapses per axon, and that's sort of this chemical connectivity where they exchange neurotransmitters across a synapse or the synaptic cleft, and then you get this sort of signaling that occurs, and it's more refined than the gap junction connections. So that's what they have here, and what they have here is nice because you have this data set that starts in L1, which is the first larval stage, and then you're moving towards adulthood, which is like after development. But you get this plasticity of the synapses. So they're showing, they show the anatomy here, but they show how the synapses fluctuate in larval development. So you see that they have these graphs of the synapses, and they do counts of synapses, and you have synapses that form, synapses that disappear, and these are all thought to be kind of product of plasticity. So if you use certain synapses, if you're signaling between two cells a lot, you're going to have more synapses. If there's a certain neurotransmitter that's involved and that gets used a lot, then there are going to be a lot more synapses, and so forth. So this is kind of what they're trying to understand, is how much plasticity is there in synaptic counts per connection. And so that tells us something maybe about how different parts of the connectome are plastic, how much they're being influenced by environment, things like that. As it turns out, the cellular morphology of C. elegans is pretty deterministic. That is, you can pretty much predict what the cells are going to look like, and you can pretty much predict what this connectome will look like in terms of its individual cells. However, you do have this enormous plasticity in terms of synaptic growth and maintenance. And so that's what they're doing in this data set. So the number of synapses is fluctuating over time. You're getting this sort of signal for plasticity, and you get a lot of plasticity actually in the larval stages. So going from L1 to L2 to L3 to L4, the worm is becoming an adult. But it's also experiencing a lot of plasticity. There's several modes of environmental protection and other types of environmental mediated plasticity at that point, where it affects the nervous system, how it sort of functions, and that sort of thing. So you see those in these data that we have here. So I would play with these data, and I would kind of treat the synapse counts as sort of these properties of sort of the edges of the network. How strong are the edges? So if you have more synapses, that means the edge is stronger. If you have fewer synapses, it maybe means it's less. And they actually go and categorize the types of synapses that you have. So you have some that are sort of transient in development. They kind of show up at maybe like L2 and then disappear. And we don't really fully know why that happens, but it's probably due to environmental plasticity and learning. And then there are other ones that are persistent, and then other ones that are environmentally driven. Like if you have this, say, response to starvation, which happens in development a lot, you get this neural protection by adding in synapses. So that's and then we can kind of look at the dynamics there, because we have the signal fluctuates quite a bit. We have like this stochastic component. We have this deterministic component, I guess, and we can look at that. So yeah.
So that three questions. One is like, so the thing is it like purely deterministic, or there are some like fluctuation that is there?
Yeah, I think the connections between the cells are deterministic. You're always going to have, that basic, the cells that are in the connectome. So the cells are going to be deterministic. The connections between them, I guess, also, well, at least their existence should be deterministic. And then their strength, however, is fluctuating. Their strength is, I wouldn't say it's stochastic, but it's definitely, maybe has a stochastic component to it.
Okay. So the other question is, does it change from one worm to other worm? For human brain, so one human is like my connection will be little different than yours. The connection strength. So is it similar for this also?
Well, yeah, the strength could vary between worms. I think in this case they just provide snapshots in time. So this, I don't know if these are. I don't think they're the same worm, but I mean, you're basically dealing in averages or something like this. I wouldn't worry about like individual variation, and I don't think it matters that. I mean, the cells are always the same, and there's always going to be some connection between them. The strength is going to be variable, and then the question is it why? Is it if it's like environmental, then one worm will do something and another worm will do something else, and they'll experience the world differently. But we know that like because of that fluctuation, it's just we on a population level we can chalk it up to like that it's variable, it fluctuates, and it might be stochastic, it might be driven by environment. We can't say that, but we can show the dynamics of it. So I would like definitely say that like the human brain, we have cells that are variable. So if you try to trace out like a connectome in humans, the cells and the nodes will be variable, but not that variable. You're going to have basically this, similar patterns of connectivity. In C. elegans, however, the cells are all deterministic, and the connections are more or less deterministic. And so that's that part. And then these synaptic connections are going to be the thing that fluctuates.
Okay. Okay. So another question is the last question. That is, like these are the snapshots 1, 2, 3, 4. So I think four snapshots they have taken from L1, then one they have taken from L2.
Yeah.
So like if we can predict something in between, suppose like 6 and 7, if we can predict something, what I mean, it's just some prediction.
Yeah.
So that, is it valuable for the community?
It might be. I mean, I don't know. I don't know why they didn't sample L4, but it's
Yeah.
L4 is kind of like right before you hit adulthood. So a lot of the plasticity happens in these time points that they sampled, like between L1 and L3. That's where you get like this dour stage. That's where you get like a starvation response. That's where you get some of the early stuff that's kind of coming online. So I would maybe it would be good to have that prediction, but it's not. I mean, it just it would be nice to build a model and see what you could predict with it. It would be interesting.
Okay. Okay. Thanks. Then I'll try to model this as a TTDG and probably I'll try some intermediate steps or intermediate prediction how the connection will look like.
Yeah.
So thank you. I think this can be I'll do for next few weeks.
All right. All right. Thanks. All right. So thank you for your updates. Now, in terms of your evaluations, I need to do these in the next week. So I will do those. And my position on this is that if you've been doing work and attending the meetings and engaging, then you pretty much will pass. And I'll give you some suggestions on how to improve things. And it's not, it's a formality basically. And it's not going to, like, I'm not going to say you failed, or I think all of you have been doing decently. So that's good. And I think, again, if you're not sticking to your schedule, that's fine, because that's kind of the point of the program, is to kind of figure out how to manage a project if you hit if you struggle and hit roadblocks. That's just the way it is, and we just need to kind of work through them, and that's kind of part of success, is in getting through those barriers. I don't want to make you sweat it out too much, but I think everyone here has done well. So thank you, everyone, for your updates. Now I wanted to get to, I know Morgan is here and Jesse is here, and they haven't had any opportunity to say anything here. So I don't know if Jesse had something you wanted to talk about today. Or Morgan?
What I might do is, in the interest of time, because we have a lot of very important updates, I did prepare
a little presentation on the question that was raised last time about explaining the mixed audience. I don't think I'll go into it, in part because I want to add a few more nice images to the slide, and I'll do like the full discussion next time. But I'll tease it. Maybe
Yeah,
I think
that's
I might
good.
do a
That'd be
tease.
good.
And I don't know if Morgan, I'm going to pull that up here and like I'm getting it on this particular screen right now. But I don't know if Morgan wants to say anything in the meantime. There we go.
Just yeah, loving the presentations, and yeah, hoping to dig into some of them at some point. I just haven't had time to focus, but
Okay.
Well, good.
My just my teaser is this. It's pretty much done, but it's nice because I'm actually doing this for a combined set of things. This came up with I'm doing some things with the Brady School at San Diego, the management school, and this isn't quite related to it, but I'm basically tailoring this to be a presentation that I can reuse in many circumstances. So I'll use it here. I'll use a version of it here, and then a version of it in some other places. One of the key points of why I'm kind of jokingly saying that is, here's what I'll talk about loose a bit. Is the first rule is know thy audience. Like, if possible, know it as much as you can ahead of time. And my preview is like, if you don't know what you're walking into, or you're asked to give a very general presentation, number one, it's kind of on the organizer to tell you, like you really should know. But if not, you can ask the audience too. But really knowing the ratio. I think the question originally came from like a balanced perspective. Oh, what if you have experts and other people in your audience, and you have a mixed group? Then yeah, like you kind of want to do the classic. I want to put a nicer image here. You can do the classic thing about starting broad, going deep. You want to have a little mix of I think there's like, I'm gonna make this nicer too, but you want to have a like for the younger or the newer group, you want to have a lot of motivation. You don't want to overload the slides. You don't want to get bogged down in jargon. And for experts, you do want to have rigor. You do want to reference data, and you don't want to oversimplify models. I think a lot of it is just really the other key thing I'm going to say is I think, where did I put it? I can't find it, but basically, it's really about finding ways. I'll just go back to this. It's kind of about finding ways to make your key points very coherently, and then not diluting them. And you can reference dependency. This is one thing that I really took away from my time at this pitching event. But it's sort of, knowing the audience, how can you tailor it? And then one of the things I'm learning how to kind of talk about too, and what I really want to get at and refine for when I do the full version of the presentation, and maybe Bradley, you could speak on this briefly now, or we can talk about it later. When I was in my first neuroscience lab some years ago, it was my first exposure. Like the PI was very good at certain professional things, and very much on the tenure track of getting papers and publications and conferences and clout and rep. So they had a lot of good insight from that particular perspective. And they introduced me to essentially what I kind of consider being like full stack, like the full stack or the full spectrum, going all the way down to the technical details of what is this bit of data? How does it show something? How does the data reflect a theory or a paradigm? What does it mean in the actual, broader spectrum of knowledge in that space? And then how do you relate that to convey that to the audience? And the norms change quite a bit, I would say, depending on who is in your audience and who you're trying to direct. I go into some diagram stuff and then expert writing and a few other things. But we'll get into that more next time. But this is sort of a nice preview for that. So if anyone has any other specific I don't know, comments or questions to add on to that would fit in this category that we can refine for when we talk about it more next time, let me know. But otherwise, that'll be just a teaser for a longer presentation ahead.
Well, that's pretty nice and well thought out, and I think pretty valuable for people thinking about giving presentations. My philosophy is you can't ever think too hard about that, like, or you want to give a presentation, but you want to keep making it better. Like a lot of people will have if you do like a project, you'll have a presentation that you might give over and over again, or you might have like a presentation that you take slides out of and bring to the next presentation. So you want to have everything worked out, and then like sometimes you want to maybe have a visual language. So like want to have, if I give a presentation to group X on one of our projects, I'll give a presentation to group Y on the same project. It'll be different, but it'll take a lot of the slides. It'll incorporate a lot of the same things, and I want to have some continuity there. And that's one way people approach this. So when you get to a point where you're giving talks in different places, you don't want to keep reinventing the wheel and doing presentations from scratch over and over. You'll take things from your previous slides and kind of recombine them. That being said, the different audiences deserve different sort of motivations, different sort of like approaches. So you say, okay, this is a group of maybe undergrads. This is a group like a conference. This is a group of just general audience. So I want every one of those talks to be different in how I motivate my problem or how much detail I get into. That's something you mentioned.
It's something that it's been a really, and maybe this is something I'll try to 1 second. Something actually I may try to. Oh, sorry. I may try to squeeze it into the same presentation, or make an adjacent one, because there's sort of a follow up broad component. This is a slightly higher level thing to say, but I think it's really worth mentioning to folks coming into the space of being like academic communicators or whatever, is over my, I don't know, history or career or whatever you want to call it, over my development as whatever I am now in terms of being an expert or familiar with the space, is I would notice occasionally basically what Bradley said in different forms. Like at one time I would see people, I know two different people. One was Josh Tenenbaum, who I mentioned glowingly at times. Another is Ruha Benjamin, who's a sociologist and a tech person. And Ruha is using some of the exact same slides from 2019. So that's 6 years of the same slides. And why? Because one, they're very good slides. But like they attach a certain visual branding and style, which is really cool for like doing public facing stuff. But there's different elements. When I was kind of along the way, I was just like, geez, like Josh Tenenbaum's like, you're making the same talk you did at this other event. And it can be true. And what I understand now is that it may be, there are varying degrees of it, and varying degrees of one, sometimes when you get into like deeper academic stuff, like you can't make a brand new talk every time. And two, maybe you shouldn't. And so it's this weird mix. It's very much this art of how do you manage the audiences, keep a coherency for people coming at it from different angles. So you can kind of see this, like a great example of this maybe right now is Michael Levin and now that he has his own YouTube channel and blog, like you'll see him reference these stock quotes of James and intelligence, or referencing the teleology diagram often, and things like that, and bridging to it, and it's really useful in that level. And in addition to understanding what is it like as a presenter who does something more often than not, I'm gonna do one more teaser thing
Okay.
because it's right here, and I really like this point. If I can find it somewhere in here. Yeah, I say this here. Drivers are people from different expertise levels and so on. And I say developing familiarity. I cross out confidence and write familiarity in speaking to different audiences, because I think sometimes we focus on confidence in a very particular way of delivering, and it does matter. But I think as a precursor, like if you're just starting out, get familiarity first, and I'll go into that more next time. But what I mean by familiarity is exposure to what it's like speaking in those spaces, and just at least the confidence, but focus on familiarity as in it's not weird, it's not new. You kind of do it. And I'm even thinking about ways to sort of test this with like Chat GTP or other simulated responses that you can do it, because you can't always pull, an expert and say, hey, I want to get familiar talking to an expert, in this way. That said, my last point about all this is, and it fits very interestingly and nicely with what Bradley was saying, I think, is that the more you do certain presentations, my evolution has come from a sense of, if you're giving a presentation, or like somewhere in the start, maybe at the conclusion slide, I say something like, oh, transferring, a technical talk isn't just transferring information, it's like building shared understanding or cultivating something. And then I say something about trajectories, which is sort of my buzzword anyway, but almost like seeing a talk more as a living, I don't want to say living document, but when you're giving these talks over time, it's more of a flow of where the conversation is going, and kind of understanding that each conversation, unless you're delivering a very routine lecture, but each conversation is going to kind of be a different layer, a different sort of layer of paint on it, and it's much more continuous as you do it more and more often than sort of a discrete, abstract, isolated conveying down, not a download or an upload. It's kind of versions and iterations, even in the talks that you give. So that was maybe way broad in a different direction, but again, if anyone wants to add specific questions to that, please put that in Slack and we can cover it next time.
Okay, yeah, thank you. That was very good. And I look forward to kind of seeing the next version of this. Yeah. All right, so thanks for attending, and we'll see you next week.
Take care, everybody.
Take care. Thank you.